you guys, welcome to Skill 18, solving exponential equations. So remember, an exponential equation is something where our variable is the exponent. And something that makes it is something that we solve for is that part is just set equal to something else. So that we're going to learn how to solve something like that today. We have this basic principle on canceling bases. So if I gave you this and asked you what does x equal, you guys would probably say that 2 equals x. That's because when our bases are the same, we know our exponents are the same. If I gave you something like this, you could still hold that same logic, that since our bases are the same, our exponents are the same. And the overall rule is so we're going to keep this in mind as we continue. If our bases are the same, then our exponents have to be equal. So right now when I see this, my bases are not the same. But I can rewrite 29 and 3 can both be written with the same base. And that's base 3 for us. So 27 can be written as 3 to the third. Once my bases are the same, I can set my exponents equal. One half equals x. We have the same idea here. So the first thing I want to do is, or sorry, we could have added the note, rewrite same bases, and then we'd set exponents equal. So we're going to try that same process here, rewrite. I can rewrite these both base 2. So 2 to the third is 8. Two squared is 4. Then I can set exponents equal. And then I can just solve for my x. Okay, moving on, you guys are going to this factoring chart that we've been referring to. It's in Alex under resources. Go ahead and find that because we will need it coming up. So I'm still going to follow my same process of rewriting with the same bases. 6 and 36 can be both base 6 actually, so I can keep this one as it is. Then I can set my exponents equal. I need an ACB tree for this, ABC. So A times C is 3. What two numbers multiply to 3 but add to my B of -4? And those two numbers would be -3 and -1. So I can write this as I can rewrite my -4x as oh, guys, I'm going crazy. This should be a 1. I can group them. I'd pull out an x. I'd pull out a -1. And to solve these, I would set each factor equal to 0. And x is equal to 1. So that's what we would do if we have to if when we set the bases equal, we have something with a quadratic. So I kind of run into something here. If I wanted to rewrite 11 and 12 with the same bases, I cannot. So what I would do is I would apply the power rule of logs. So if I take the log of both sides, I can then bring my variable to the front. I can divide by everything but y. So divide by 5 log 11. Divide by 5 log 11. And then when I put that in a calculator, I get 0.207. It asked me to round to the nearest hundredths, so that's 2 decimals. So I'd round to 0.21. We're going to try another one like this. 4 and 6, I cannot write with the same bases. My calculator can take log base 10, so I'd take log base 10 of both sides. I'd apply the power rule. Divide both sides by log 4. Now I'm just doing whatever work I need to do to actually get y by itself. Subtract 3 from both sides. It asks us to round to the nearest hundredth again. So that means I only want 2 decimal places. So that would round at -1.71. Similar to what we've done, ln or e in 4 cannot be written as the same basis, but instead of taking the log of both sides, I'm going to take the ln of both sides. Then I can bring that to the front. There's a couple ways we can handle it from here. We know this cancels to 1. Then we get y equals ln of 5 divided by ln of 4. That's when we could have handled it, or once we got to this part, we could have handled it if we divided everything. We would have still gotten the same answer. So it didn't technically, if you didn't cancel that there, that's okay. We're going to practice this one more time. I'll show both ways again. So if I were to take the ln of both sides, because 8 and or e and 4 are not going to be the same ones. I think of it that this reduces. If I were to round that to the nearest hundredth, I get that. Or I can think of it if you don't want to cancel it out, you can think of it this way. Divide everything by ln of e. And you can subtract your 8.